let's see what the first and second derivatives can tell us about a function. We have an increasing-decreasing test that tells us that if the first derivative of the function is positive on an interval, then the values of the function must increase on that interval. Whereas if the first derivative is negative on an interval, then the values of the function must decrease on that interval. Then we have the first derivative test, which tells us that if we have a critical point c, at which the first derivative of our function changes sign, then the function must have a maximum or a minimum at c. A maximum if the first derivative goes from positive values to negative values, and a minimum if the first derivative goes from being negative to positive. And this makes sense when you compare it with the increasing-decreasing test, because a positive first derivative means that the function is increasing and then goes to decreasing as the first derivative becomes negative. So the function must have a maximum at that point where the derivative changes sign from positive to negative, whereas the first derivative being negative means the function is decreasing, and then changing sign to positive means that function starts increasing. So at that point where the change of sign from negative to positive happens, the function must have a minimum. The concavity test is involving the second derivative of our function, and it tells us that if the second derivative is positive on an open interval, then the function is convex on that interval. Convex means that the function's graph is below any secant line. Whereas if the second derivative is negative on an open interval, then the function is concave on that interval, and concave means that the graph of the function is above secant lines. Then we have the second derivative test, which tells us that if we have a critical point c of our function, and the second derivative of the function is continuous near this point c, then the function must have a maximum or a minimum at c. A maximum if the second derivative at c is negative, and a minimum if the second derivative at c is positive. With the concavity test, the second derivative test makes sense, because having negative second derivative at c means that the function's graph is concave, therefore at c we have a maximum, whereas having positive second derivative at c, that means that the function near c is convex, therefore we have a minimum at c. Okay, this is enough for now. Let's solve some problems. Select all intervals on which the function f of x equals x cubed minus 3x is increasing. So pause the video and make your selection now. I hope you paused it and have selected these two intervals. So to find where the function is increasing, we apply the increasing-decreasing test, for which we need the first derivative of the function. So this function has the first derivative that is 3 times x squared minus 3, or 3 times x squared minus 1. And so this first derivative is positive and the function is increasing if x squared is greater than 1. And that happens if and only if x is less than negative 1 or x is greater than 1. So these are those two intervals. Let's look at the next question. Use the first derivative test to find the critical point c at which the function f of x equals x plus 4 over x has a minimum on the interval between 0 and infinity. Pause the video and input your answer in the box. Hope you paused it and have inputted c equals 2, so 2 is this critical point. First, let's find it. So we find the critical point by looking at the derivative of the function. This, on that interval, open interval, has a derivative at every point, so we need to find where the derivative vanishes, where it becomes 0. The derivative function is 1 minus 4 over x squared, which is 0 if and only if x squared is equal to 4, so x is equal to 2. X equals negative 2 would also be a solution, but it wouldn't be in that interval, so we only keep the critical point, which is in that interval, x equals 2. Now, to see whether it's a minimum or a maximum, we use the first derivative test and look at this first derivative, which is 1 minus 4 over x squared, or x squared minus 4 over x squared. It can be also written like this, and see what happens to the values of this first derivative at x equals 2, or around x equals 2. If x is slightly less than 2, then x squared minus 4 is negative, and so it goes from negative to positive, because if x is slightly greater than 2, then x squared minus 4 is positive, x squared is of course positive, so it goes from negative values to positive values, the first derivative that is, at 2. Therefore, by the first derivative test, it means that the function has a minimum at 2. Let's look at the next question. Select all intervals on which the function f of x equals x cubed plus 5x minus 2 is convex. Pause the video and make your selection now. Hope you paused it and I've selected these two intervals. Well, to find where the function is convex, we need to find where the second derivative is positive. So let's first compute the first derivative of our function f. We get that be 3 times x squared plus 5. Its derivative, so the second derivative of our function, would be 6x. And to see where this is positive, we just have to look at where 6x is positive, and that happens exactly when x is positive. Therefore, by the concavity test, we see that f is convex for all x between 0 and infinity, and the points between 0 and 1 also are contained in that interval. Let's look at the next question. Use the second derivative test to find a critical point c at which the function f of x equals x plus 1 multiplied by e to the minus x has a maximum. So pause the video and input your answer in the box. Hope you paused it and have found that the critical point is c equals 0. This function is differentiable everywhere, so the video and input your answer in the box. Hope you paused it and have found that the critical point is c equals 0. This function is differentiable everywhere, so the critical point occurs where the first derivative of the function vanishes, becomes 0. The first derivative of this function is, well, by the product rule, is e to the minus x minus x plus 1 times e to the minus x. So if you collect the terms, expand the brackets, you will be left with x times e to the minus x. So this is 0 if and only if x is equal to 0, as the exponential never becomes 0. So 0 is the critical point, and to apply the second derivative test, we need to evaluate the second derivative of our function, which is going to be continuous at around 0. At 0, so what is the second derivative of this function is minus e to the minus x plus x times e to the minus x. So if we collect the terms, we get x minus 1 times e to the minus x. Evaluating the second derivative at the critical point 0, we get negative 1 times e to the 0, which is minus 1, is a negative number. Therefore, by the second derivative test, we have a maximum at that critical point 0. I hope you enjoyed this video, and I'll see you in the next one.